Now, dear student of class 12, we have already finished first order derivative. Now, today's topic is second order derivative. Now, how to get the second order derivative? You have to calculate the first order derivative, that is dy by dx, or I'll write, let us suppose y is equals to fx. Now, differentiate this function. Differentiating with respect to x, you'll get dy by dx equals to f dash x. Now this one is first order derivative. Now if you differentiate the first order derivative, you'll get the second order derivative. Now then I'll write again, differentiating with respect to x. Now dy by dx with respect to x means, now we'll write d2y by dx square, and the derivative of f dash x will be f double dash x. Now you can say the dy by dx with respect to x is, actually this one is dy by dx of dy by dx, that is d2y by dx square, or you can say d square y by dx square. Now this one is the second order derivative. Whatever the answer you will get in first order derivative, again if you differentiate that particular answer, you will get the second order derivative. Now this one is the concept. Now the second order derivative can represent it by d2y by dx square, f double dash x, or first of all, enough say first order derivative dy by dx. You can represent it by y1 also, or y dash. Instead of writing dy by dx, now in second order derivative you can write y1 or y dash. Now further, if you differentiate this quantity, you will get d2y by, or f double dash x also you can use. d2y by dx square means this is y2 or y double dash or f double dash x. Now according to the questions, that you have to use this notation in case of second order derivative. dy by dx, y1, y dash, f double dash x, these are the same thing, first order derivative. If you differentiate this four quantity with respect to x, again you will get d2y by dx square, y2, y double dash, or f double dash x. This one is the entire concept of second order derivative. Now I'll apply these things numerically. Now first take a screenshot of these things. Now y is equals to x to the power 5. Now find d2y by dx square. Now what you have to do is, first you have to calculate the first order derivative, differentiating with respect to x. Differentiating with respect to x means y with respect to x is dy by dx equals to derivative of x to the power 5 is 5x to the power 4. Now this one is first order. To calculate the second order, what you have to write again, differentiating with respect to x. dy by dx with respect to x means we'll write d2y by dx square equals to 5, only the variable that you have to differentiate over here. Derivative of x to the power 4 will be 4x to the power 4 minus 1, 3. 5 4s are 20 x cube. Now this one is the second order derivative. Next question is, y is equals to 3 log x, find d2y by dx square. Now differentiating with respect to x, dy by dx equals to 3, and the derivative log x is 1 by x, 3 into 1 by x. Again differentiating with respect to x, this one will be d2y by dx square is equals to 3 into derivative of 1 by x is minus 1 upon x square. Now the answer will be 3 by x square. another question. Y is equals to e to the power x plus sin x. Find d2y by dx square. Now differentiating with respect to x, dy by dx. Derivative e to the power x is e to the power x plus derivative sin x is cos x. Again, differentiating with respect to x, you'll get d2y by dx square. Again, the derivative e to the power x is e to the power x plus derivative of cos x is minus sin x. Now it is e to the power x plus into minus minus sin x is the final answer. Y is equals to tan inverse x. Find d2y by dx square. Now differentiating with respect to x, this one will be dy by dx, and derivative of tan inverse x is 1 by 1 plus x square. To calculate the second order derivative, we cannot use u upon v formula because the numerator is constant, denominator is variable. In this case, we cannot use formula, so we'll consider the index of this quantity is 1. Now then, I'll convert this things in terms of inverse form. So 1 plus x squared to the power minus 1. Then I'll use x to the power n. Again, differentiating with respect to x, we'll get d2y by dx square equals to, this whole thing is considered as x to the power n. Formula is n x to the power n minus 1 into the derivative of this inner function. Derivative 1 is 0 plus derivative x square is 2x. The final answer will be minus 1 plus x squared to the power minus 2 into 2x. Now then, we can write this is equals to 2x over 1 plus x square whole square. This is the required answer. Now next is y is equals to log x into cos x. Find d2y by dx square. Now I'll differentiate. Differentiating with respect to x, dy by dx. Derivative of log cos x. First log 1 over cos x into the derivative cos x is minus sin x. Now we have sin x over cos x here. Minus sin x over cos x is tan x. Now again, differentiating with respect to x, what you will get d2y by dx square is equals to minus derivative tan x is sec square x. This one is the final answer. Now from second order, this much of concept today we'll do. The next class I'll do some proving. Thank you.